Hello and welcome back to conceptual geospatial solutions. So in this video, we are going to see how to calculate time using the longitudinal values and the other way around. So first of all, if you're new to the concept of latitudes and longitudes, then I suggest you to have a look at one of our previous videos in which I've discussed the concept of both the latitudes and longitudes in detail. So for your convenience, I have given the link of that video in the description of this video. So should you wish to learn them, please have a look at it. So as we discussed in our previous video, longitudinal lines are called the meridians, and each meridian will be acting as a great circle. That is, it will be having two arms, with one arm being called the meridian and the other called the anti-meridian. So as you can see from this picture, each meridian will be having another arm on the other side of the globe, so that the entire globe is covered by longitudinal lines of 360 degrees. Longitudinal lines are of 360 degrees. In total, right? Okay, so now we know that one complete rotation of Earth will be taking a time of 24 hours. So let's see how it is calculated. So for that, first you have to understand that Earth's rotation will be taking a time of 4 minutes to cross 1 degree of longitude. Let me highlight this in red color because this is the most important thumb rule when it comes to calculating the time of a particular place using the longitudinal value. It can also be said as the difference between any two lines of longitude is 4 minutes on any place on the globe. So we have come to know that the time taken to traverse 1 degree of longitude is 4 minutes. So if you want to compute the time taken to traverse this entire globe, we have to just multiply this 360 degrees by 4 minutes. Since the time taken to traverse 1 degree is 4 minutes, if you multiply this 360 by 4 minutes, you will be getting the time taken to traverse the entire globe, right? So if you do that, you will be getting a value of 1440 minutes. And if you convert that by dividing it by 60, it is 24 hours. So in this way, it is computed that the total time taken for one complete rotation of Earth is 24 hours. So now we shall discuss about the GMT zones. And as you can see from this picture, the GMT zones are also called the UTC zones, that is the Universal Time Code zones. And this particular zone of value 0 is where the longitudinal line of 0 degrees passes through. This longitudinal line passes over the Greenwich Observatory, which is located in UK. And as you can see here, as we progress towards the eastern side, the time increases by 1 hour. And as you progress towards the western side, the time decreases by 1 hour in each zone. So I hope you have understood all the basic concepts which I have discussed. So let me put that into use here. So let's have a look at our first problem here. So it states that a cricket match was to be held at Birmingham at 9 a.m. local time. And the position of Birmingham is 5 degrees west from the prime meridian. So it has a time that is slower than the Greenwich Mean Time, right? So now we have to calculate the time at Sydney. And the longitudinal value of Sydney is 151 degrees towards east from the Greenwich Mean Time. So first what you have to do here is, so for that, first you have to note the directions in which these two places are located. Say for instance, Birmingham is located towards the west of the GMT, while Sydney is located towards the east of the GMT. So since they are in two different directions, we have to add the longitudinal values of these two places. And suppose if two places are in the same direction, that is, if two locations are in the western quadrant or in the eastern quadrant, then we have to find the difference between the values of those two locations. But since in this case, the two locations are on different quadrants, that is, the one being the western quadrant and the other being the eastern quadrant, we have to add the values of these two locations. So, with that being said, we have to just add the longitudinal values of Birmingham and Sydney, which will give us a value of 5 plus 151, that is 156 degrees. So what it means is that these two locations are 156 degrees apart. So we have already seen that the Earth will take a time of 4 minutes to cross 1 degree of longitude. In keeping with the calculation, if we multiply this 156 by 4, let me open the calculator. 156 by 4, we will be getting the value of 624. So this is the time difference between these two places, that is, it is 624 minutes. The time between these two places are 624 minutes apart. So this 624 can also be written as 600 plus 24, right? 600 minutes plus 24 minutes. That is 600 minutes is equal to 10 hours, right? So it is 10 hours and 24 minutes. Time at Sydney is 10 hours and 24 minutes ahead of the time at Birmingham. So since the time at Birmingham is already given here as 9 a.m., so you have to just add this 10 hours and 24 minutes to this 9 a.m. time. So should we do that, it is 9 plus 10 hours and 24 minutes, which will give us a value of 19 hours and 24 minutes, which is nothing but 7:24 p.m. So the time at Sydney is 7:24 p.m. when it was 9 a.m. at Birmingham. So let's take a look at another problem. So in this case, you have been asked to find out the longitude of a particular place, which has a time of 1:15 p.m. and we have been given the time of Chicago, and it is 80 degrees west of the prime meridian. So in this case, first you have to find out the time difference between these two places. So for that, this 1:15 p.m. Can also be written as 13 hours and 15 minutes, right? So it is 13 hours and 15 minutes minus 4 hours, which is equal to 9 hours and 15 minutes. So these two places are 9 hours and 15 minutes apart. And if you convert this hours into minutes, that is, if you multiply this 9 by 60, it is 540 minutes plus 15 minutes, which is equal to 555 minutes. So these two places are 555 minutes apart from each other. So now we have to convert these minutes to degrees. So please keep it in mind. If you want to convert the minutes to degrees, you have to divide the minutes by 4. And if you want to convert the degrees to minutes, you have to multiply the degrees by 4. So in this case, we are going to convert the minutes to degrees. So for that, you have to divide this 555 by 4, which will give us a value of, let me open the calculator again. So it is 555 divided by 4, it is 138.75 degrees. So it is 138.75 degrees, which can also be written as 138 degrees and 45 minutes. If you convert this 0.75 degrees into minutes, it is 45 minutes. So these two places are 138 degrees and 45 minutes apart from each other. So what we have to do now is that we have to subtract this 88 degrees from this 138 degrees and 45 minutes. So if you do that, 138 degrees, 45 minutes, minus 88 degrees. So it is 138 minus 88, which will give us a value of 50. And this 45 minutes will be as it is, right? So it is 50 degrees and 45 minutes towards the east of the prime meridian, right? So the reason for subtracting this 88 degrees from this total value of 138 degrees and 45 minutes is that since this value is towards the west of the prime meridian, we have to first subtract it, as we are trying to find out the location of this particular place only with respect to the GMT. It is important that we have to subtract this value so that you will be getting to know how far this particular place is from the GMT. So I hope you have understood the concept clearly here. So with this, we have learned the concept of calculating time from the longitude values and vice versa. So I hope this topic was of some use to you. And should you have any queries, please feel free to ask. I'll be glad to answer it out. So thank you so much for watching, and please do support my channel for further interesting topics.